Okay, so in the previous lesson, we looked at integration by parts, and we finished off with some sort of unusual cases like natural log of x. So partial fractions then. So the next thing we can do is we can actually connect our work quite a while ago now on partial fractions with integration. Okay, so something like this one here, the trick is we use partial fractions on it, and then it's much easier to integrate. So partial fractions is something you use when you can identify a product in the denominator. So this must be, you must be able to write this in this form. Okay, for any value of x. So that's what partial fractions is all about. You weren't sort of told explicitly there was a product, but you need to identify that that's the difference of two squares. So you can do, something like this. Okay. Um, and then when we want to integrate this, well, we can sort of just integrate them separately. That's the advantage when you've got that plus or a minus sign there. And natural logs are the way to go. So, for example, if we had, I'm just making this up, I don't know if this is a number or not. If we had something like this and we want to integrate this, well, that's going to be the natural log of x plus 1. Okay. And just check with the chain rule, it wouldn't cause any problems. So let's have a look at our example here. So the value that it goes above the x plus 1 should be a minus 1, apparently. So what you do is you'd integrate, you could do something like this if you want. And then above b, so above the x minus 1, you should get the value of 1. You might want to swap these. So I would swap the order. I would do the integral of 1 1 over x minus 1 minus, and I'd still put the minus sign between them. That's the way I would handle it. 1x plus 1. Okay. So then you've got your natural log of x minus 1 minus the natural log of x plus 1. And remember, if logs have the same base, you can do the quotient of them. So you can do x minus 1 over x plus 1. Okay, like this one here. Don't forget the c. So partial fractions come together then with integration questions. Very common combination. Here's another one here. So again, the idea with partial fractions is that we can write this as some number over x plus 1 plus some number over x minus 2. And the answer is going to feature something about log of this and log of that in this case. So this is what it turns into. If you have a 2, my advice would be to do something like this. So do the natural log, so do the integral of 2 times, you can kind of keep the 2 at the front. Yeah, pull the 2 out, and then you have 1 over x plus 1. It's a bit easier to handle that. So the 2 sits out the front, then you get the natural log. Okay, that's how I would integrate to get that result on that first piece. Yeah, the x minus 2, there's nothing really that different there. Don't forget as well, if you have logs, anything in front of the log, a number there, you can move that as a power. So that has moved as a power. It's now become to the power of 2. Yeah. And then finally, we put them together using log rules, okay, with the plus c. Something like this is more difficult, more likely to trip you up. This has a repeated factor. So this is going to be a number over 2x plus 1 plus a number over x minus 2 plus a number over x minus 2 squared. So that's the special case of the repeated factor appearing there. You need to watch out for that one. I'm going to actually sort of jump ahead a little bit and take the answer for the ABC. Let's take the answer for the ABC. I'll just put it over there for now. Okay. So if we pretend I've done that, I get these values. So now you want to integrate, yeah, if we use this, now you want to integrate 2 over 2x plus 1 minus 1 over x minus 2 squared plus 3 over x minus 2. This one here, if you do the natural log of 2x plus 1, you'd get this on the denominator, but you'd have a chain rule that would create a 2 but you actually wanted to, because look, there's a 2 up there already. So in this situation, it's good if you didn't pull the 2 out and you just experimented with the denominator first, because that is the first part there. It already works. Over here, you need to watch out for this one. This is not a natural log. This term is the same as x minus 2 to the minus 2. Okay? So no natural logs for this one, please, because look, this is a bracket to the power of 1, a bracket to the power of 1. That's when we use logs in the denominator, not when you have a power for the whole denominator. Okay? Try x minus 1 to the minus 1, but then you'd have to divide by that new power. So that's what it should be. Okay? That's what it is when we integrate it. There's also a negative there already, so this is actually a double negative. X minus 1 to the minus 1. And this one's a bit nicer. Put the 3 at the front, natural log of x minus 2. Okay, so that can be a plus. If you want to put the logs together and there's a number at the front, move that number up to the power. So this is the same as the natural log of 2x plus 1 plus the natural log of x minus 2 all cubed plus x minus 1 to the minus 1. And then you could put these together. Okay, so you could say it's the natural log of 2x plus 1 multiplied by x minus 2 cubed plus this bit here plus c. Okay, quite a long example, that one. But then you get a fair amount of credit to sort of reflect that. So it's got the repeated factor here. It's got an interesting situation where the reverse chain rule sort of guides you towards the 2 is quite useful there. It's got this thing where we need to be really, really careful, and it's not a log, even though it looks like it. We're talking about moving coefficients, constants here at the front, to the power, and then using log rules. There's a lot of stuff going on there now. Okay, so you really cannot have any gaps in your partial fractions. You might need to revisit that if it's a bit shaky. So pause the video, have a quick go at that one there on the board, and we'll have a look at it together. So we're looking for 4 over 2x plus 1, minus 3 over the x plus 1, and 1 over the x plus 3. Hence, integrate it. Well, once we've done all of that, so we actually put the numbers in, and we should get this one here when we integrate. Okay, so they're talking about doing the reverse sort of chain thing there with the 2. Don't forget that 2 creates another 2, so you have to divide by it. The middle term looks fairly straightforward for this kind of question, and this one here. And that's all they want. Okay, that's all they want here. They haven't asked you to put it all together with log rules, but maybe they could. Finally, you've got to put some limits into this one. So 2 into everything minus 1 into everything. And you've got some natural log of 1s there, for example, that just sort of disappear. Okay, 2 natural log of 5 minus 3 natural log of 5. 2 natural log of 5 plus a natural log of 5. That's where that one's coming from. Minus 3 minus another one gives you minus 4. Okay, and they've written it nice and neatly like that. Because it says in the form natural log of k. So you've got these numbers here at the front. You've got to try and move those numbers at the front to powers, and then you've got a division because of the subtraction. And we also do the same thing when it's top heavy. So remember, if the power on the top is the same as the bottom, or if the number on the top, if the power on the top, if the order exceeds, in either of these situations, we call them top heavy. Okay, and the way to deal with it is to do a division. Okay, so you do a division like this, we get our answer. And again, this should look like something from chapter 1. You get this nice neat part here, and you get your remainder still left here. There's some more straightforward integration here, and then there's logs again. So we often see logs with partial fractions when we integrate. So pause the video, have a quick go at that one there again, and I'll reveal it. Okay, so you need to divide through before you integrate. That note there is very, very good about comparing two terms in the denominator with one term in the denominator. So make sure you read that one there. And again, we've got another one. Okay, so that takes you up to the end of 11G. 11H, I'm not going to do a video on because this is just looking at how it's used. It's used for the area under curves, or if you prefer to think about the area in between curves. So, you just work out this one, for example, and then you take away this one, would leave you with that area there. Okay, so the application is the same. It's just that now you might have to do this with more difficult things, okay, using the right rule in the right place.